again. Sorry for those technical issues. Yep, looks like my mic is working now. All right, so let's start again. Good times. All right, so we are going to be multiplying polynomials, but first we're going to review multiplying a monomial by a monomial. Yep, okay, checked it on my phone. My mic is truly working. Got through half the lesson, had to restart. Awesome. Yay, technology. Anyway, so when we are multiplying monomials together, what we want to do is multiply the coefficients by the coefficients. So 5 times 2 is going to give us 10. And then the variables, we keep the base, but then since we're multiplying, we're going to add the exponents. So just a little refresher there. All right. So next, let's review regular distributing. So regular distributing is when you have one term on the outside, and then you have some polynomial on the inside. In this case, it happens to be a binomial. So we're going to distribute the 2x to both terms on the inside. So we have 2x times 3x minus 2x times 1. Which some of you might be able to do this in your head, and that's totally fine. You don't have to write this out, but it's helpful. So we have 2x times 3x. That's going to give us 6x squared. Because remember, technically, both of those are raised to the first power. And then minus 2x times 1 is 2x. That's going to be our final answer because even though the variable is the same, the exponent is not. So they are not like terms. So hopefully you feel pretty good with that concept since that was your homework due today. Hi, Mackenzie. Sorry if you were stuck on the other one where I, didn't have any volume. So let's scoochie down. I'm going to get right into the meat and potatoes of this. We're going to do example D, which there's 2 different methods to multiplying polynomials together. Specifically, these are 2 binomials. There is the double distributing method, and there's also something called the box method, which you may have done called lattice multiplication, maybe in middle school. So I'm going to show you both methods with the exact same problem. So I'll write a little petite so you have some space. So first I'm going to show you the double distribute. And it does exactly as its name sounds. You distribute doubly, or you distribute twice. So what does that mean? So that means that I'm first going to start with the first term in the first binomial, and I'm going to distribute just like I would normally to the other set of parentheses. So there we have x times x minus x times 6. And then we're going to take, I'll use a slightly different shade of blue, the second term in that first polynomial. Notice that I'm including the sign with it, okay? And we're going to distribute it to the other polynomial. So now we have plus 2 times x minus 2 times 6. And you could always say plus negative 6 as well. Either way, it doesn't matter. The step that I'm writing right here isn't even necessary. You technically don't need it. So let's put this all together. We get x squared minus 6x plus 2x minus 12. Usually when we're multiplying polynomials by each other, we're going to have some like terms. We want to make sure we're looking out for that. And we do. We have negative 6x and 2x. We can combine those together. So we end up getting x squared minus 4x minus 12. Okay. So now I'm going to do this with the box method. You're going to see we're going to get the exact same answer. So if you prefer one method over another, use the method that makes the most sense to you. Okay. So with the box method, I'm literally going to draw a box. It's going to look like a window. Draw a box with a window. What I'm going to do is, I'm going to use green actually. We're going to put the first polynomial on top, so that was x plus 2. So I have x plus 2, so it gets its own little space on that window. And then x minus 6 is going to go down. So we're going to have x minus 6. So that second term, I'm keeping the sign with it, whether it was positive or negative. Now what we're going to do is we're still going to multiply these pieces, but it's just a slightly different way to organize what's happening here. And I'm going to zoom in so it's a little nicer to see. So we are going to multiply down and across. So in that first upper left box, that's really going to be x times x, which will be x squared. The box to the right of that is going to be x times 2, which is 2x. The box in the bottom left is going to be x times negative 6, which is negative 6x. And then the last box is going to be negative 6 times 2. Or you can write 2 times negative 6, or it doesn't matter. We get negative 12. And then if you notice on that diagonal, if you do these in standard form, you will get your like terms to be on the diagonal. So, and also if we look at what we did over to the right in blue, all of those terms that we got in the box are also what we got when we double distributed. So if we put all of that together, I have x squared. If I combine negative 6x and 2x, I still get negative 4x. And then drop down my minus 12. So as you can see, no matter which way I picked, I'm still going to get the same answer. So I'm going to show that method a couple more times, and hopefully by the end of this, you'll be able to figure out which method you like the best. So let's try another one. Let's do example E. So let's see, and I'm going to cross off example F just so I'm not squishing myself for space there. So I'm just going to cross that one off. So we're going to do example E. Okay, so again, I'm going to show you, oh, I forgot to label that. Shame on me. This is the box method. Okay. So we're going to do double distributive method first, then box method, and we should get the same answer no matter what. So double distrib. Okay, so I take the first term and I distribute it to the other quantity. So we have 2x times x plus, excuse me, 2x times 3. And then I take the other term and I multiply it by both pieces in the other quantity. So plus 7 times x plus 7 times 3. And again, the more you do it, you may not even rely on having to write that step out. It's totally up to you. So 2x times x is going to be 2x squared. Remember, you're adding those exponents. Get little ones there. Plus 2x times 3 is 6x. Plus 7 times x is 7x. Plus 7 times 3 is 21. Then I gotta see, do I have any like terms? And I do. The 6x and the 7x will combine. So we're left with 2x squared plus 13x plus 21. So really, if you want to know what minimal work I want to see, I highly suggest you draw the arrows. I highly suggest. If you don't draw the arrows, you're probably going to leave something out, or somebody's going to get multiplied by the wrong thing. I've seen some crazy stuff in my days. So draw the arrows. The long step that I wrote out, you technically don't need that. I'd be fine if you left it out, but I do want to see the step with your products and then obviously your final answer. So arrows and those last two steps, is what I want to see. Okay, let's practice the box method now. So we do the same exact thing. I'm going to draw my window. Oops. Go away, keyboard. I don't need you. Oh man, it messed up my box. Ah, there we go. Oh, and then the pen froze. It's just not my tech day. It's just not my day. Ah! Now the whole computer froze. But at least I have volume this time, right? At least I have that. Okay, there we go. Box method. So we had, what was it, 2x plus 7? I already forgot. I'll do it in pink. So we have 2x plus 7, and then x plus 3. Even if it's positive, I always bring the sign down just so I don't forget about it. And then remember, we multiply down and across. Down and across. So in that first box, we get 2x times x, which is 2x squared. And again, the part that I'm writing, itty bitty teeny weeny, you don't have to write that. I'm just writing it on your notes so you know where my numbers are coming from. In the box to the right of that, what do we have? X times 7, which will give us 7x. In the bottom left, we get 2x times 3, which is 6x. And then the last box, we have 3 times 7, which is 21. And then if we look, we have some like terms. Highlighter froze. Super cool. It did it in the other box. Okay, well, it's not highlighting, but the 7x is a like term to it. I don't know why it's not highlighting. So we have 2x squared, 7x plus 6x is 13x, and then plus 21. So as we see, we still got the exact same answer no matter which method that we used. Why won't that highlight? It's going to drive me nuts. All right. So I'm going to skip around a little bit. I'm not going to do example 3. I'm going to scooch down to example 4. Okay. So I like example 4a because you will see it written out like this. I wouldn't say super common in Algebra 1, but enough where it's, you know, you should know what it means. So if I have something squared, that means that I have that quantity twice. So this means I have 2x plus 5 times 2x plus 5. I can't just distribute that exponent. It doesn't work like that. You got to write out that quantity twice. Now from here, we can choose if we want to double distribute or if we want to use box method. So I think with this one, I'm just going to do this one as double distribute, and then I'll do the next one as box method just because I don't have a ton of space on this page. So in A, I will do the double distribute. Okay. So when I double distribute, what I do is the first term gets multiplied by the other two terms in the opposite quantity. So I have 2x times 2x plus 2x times 5. And then I take the other term in my first quantity, and it gets distributed to the other one. So plus 5 times 2x plus 5 times 5. And now I can just multiply through. So 2x times 2x, that is going to give me 4x squared, plus 2x times 5 is going to give me 10x, plus 5 times 2x is going to give me 10x, plus 5 times 5 is 25. And then, of course, I need to look for like terms. I do have some like terms. So I have 4x squared plus 20x plus 25 for my final answer. So again, that was the double distributing method because we are distributing twice. Okay. On example B, I'm going to do the box method. There we go. Now you'll notice with example B, I don't just have a binomial there, I have a trinomial there. There's 3 terms. But that's okay. The box method is still going to work here. I just got to make a bigger box. So my first polynomial has 2 terms. So when I go to make my window, I need to make sure that I can fit both of them there. So I have an x plus 2. And then on the side is where my second polynomial goes. I need to fit x squared, 4x, and 3. So you see I'm just adding an extra layer to my window. If this was double distributing, I would just have to distribute one more time to that third term. So it's the same. Okay? And again, this is box method. And I actually prefer box method when I have something that's bigger than 2 terms. If you get to 3 terms and 4 terms, distributing can get a little hairy with all those arrows. So the box method is a little bit nicer to organize your work with. So let's see what we get in this box. So remember, we go down and over. Down and over. So my first box, I get x times x squared. Well, that's going to give us x cubed. Remember, there's always a little 1 right there. We don't usually write it because we're lazy. That's okay. The box to the right, we have x squared times 2, which is going to give me 2x squared. Let's go down to the second row. So that middle left box, we have 4x times x. Well, that's going to give me 4x squared. In the box next to that, we're going to have 4x times 2. That's going to give me 8x. Next, in the bottom left, we get x times 3, which is 3x. And then in the very last box, I get 3 times 2, which is 6. Now I'm going to put all of that together. I'm going to look to see if I have some like terms, which I do. I have 2x squared can be combined with 4x squared. And I also have 8x can be combined with 3x. So I have x cubed didn't have anybody, so he just comes on down. And remember, you still want your answers written in standard form, okay? And then we have 4x squared plus 2x squared. That's going to be plus 6x squared. Plus 8x plus 3x is 11x. And then that 6 doesn't have anybody, so he just comes on down too. So our answer is a little bit bigger, but still not too bad. And again, the box method is really nice for this because it really organizes it for you. Okay. Let's do one with a little bit more meat to its bones. And then we only got a couple more and then we'll be okay. Now, example C. This one's a little bit of a bigger kahuna. I know there's an update. So, you're not going to multiply all 3 of these at once. Dear God, that would just be, bleh. It would not be good. Be a hot mess express. So again, you can choose if you rather do double distributing or if you rather do the box method. I really don't care which one you do. But we're just going to be doing 2 quantities at once. So for me, I usually just start with the first 2 that are written, you know. So I'll start off with double distributive, then I'll do a little box method. Let's mix it up. It doesn't say we have to commit to one. We can do what we want as long as it's mathematically sound. So I'm going to start off with double distributing. So that means my x is going to be distributed to the other quantity. So we get x times x is x squared. X times 3 is plus 3x. Now I'm going to distribute the negative 4 to both of those. So negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. And now technically that all still needs to be in parentheses because it is being multiplied by x minus 5. Now I'm just going to clean up my like terms. So I'm going to have x squared minus x minus 12 times x minus 5. Now from here we're not done. We need to multiply that trinomial by the binomial. Now anytime I have a trinomial, I would really recommend do the box method so it doesn't get hairy. It is, if you try and do the super distributing, it's just like, well, it's a mess, okay? So my first polynomial needs 3 spots in its window. So we have x squared, negative x, and negative 12. Oops. So come on. There we go. Just pushing my computer too hard. So my window is going to be a little bit bigger here, but that's okay. And then I made my box really big. Wow, the struggle is real, Sadler. Oh my god. Ah. There we go. Okay. There we go. And then my second polynomial is x minus 5. You really could do the 3 down the side and the 2 on the top if you wanted to keep it consistent. Doesn't matter. But we're still going to multiply down and across. Down and across. And my computer froze. Oh my god. And they say let's just do all e-learning. Okay. So in my first box, I've got an x times an x squared, which is going to give me an x cubed. I have x times negative x, which is going to give me a negative x squared. A little bit more exciting. Got some negatives happening there. Did my mic go off? No, it didn't. Okay. In the next box, I have x times negative 12, which is going to give me negative 12x. Going to that bottom row, I have x squared times negative 5, which is going to give me negative 5x squared. Next to that, I have negative 5 times negative x. Well, negative times a negative is a positive, so I'm going to have positive 5x. And then next, we have negative 5 times negative 12. Negative times a negative is a positive, and that's going to give me 60. So let's look in here to see if we have any like terms. I have a negative x squared and a negative 5x squared, so those can be combined. I also have negative 12x and positive 5x. I got a bunch of like terms that can be put together here. So I have x cubed and then negative 5x squared and negative x squared. Remember, there's a coefficient of a 1 there. So that's going to be minus 6x squared. Oh, that was going to hiccup. It's coming soon. Negative 12x and positive 5x. There it is minus 7x. And then we drop down my plus 60. Cool. All right. We'll do one more, and then I'm done. One more, and then I'm done. So, example D has that quantity cubed. Similar to above when it was the quantity squared, we wrote it out twice. Well, that means here, we're going to write this out as 3x plus 2 times 3x plus 2 times 3x plus 2. You can't just distribute the exponent. It does not work like that. Oh my god, how many times is the computer going to tell me I have an update? I know! Alright, I'm going to write this down here so I have some space. Alright. No, actually I'm going to keep it up there. So, just like before, we're not going to go crazy and do all 3 of these at once. That's going to be ugly. So we're just going to pick the first 2, okay? So let's just focus on the first 2. So, pick a different color. So, that means I'm going to start with double distributing. So we have 3x. Oh, I know I'm circling that again. 3x times 3x is going to give me 9x squared. And then 3x times 2 is plus 6x. Then we move on to this positive 2. Positive 2 times 3x is positive 6x. And then positive 2 times positive 2 is positive 4. Again, I'm going to keep this in parentheses because it's still being multiplied by 3x plus 2. I do have some like terms in there, so we can clean this up a little bit. Oops. We have, that's a bad parenthesis, 9x squared plus 12x plus 4 times 3x plus 2. And again, when I've got a big polynomial like that, I'm going to go right for the box method. So let's draw a box. There we go. Okay. I have 9x squared, positive 12x, positive 4. Then I have 3x plus 2. So there's my box. And again, we multiply down and across. Down and across. So let's do green. Keep up with the green. All right. In my first box, I've got 9x squared times 3x. That is going to give me 27x cubed. And again, the part that I'm writing, itty bitty, you don't have to write that, but it's helpful. Okay. Next, we have 3x times 12x. 3x times 12x, what's that? 36x squared. In the box next to that, we have 3x times 4. That's going to be 12x. Moving down to the bottom row, we have 9x squared times 2. That's going to give me 18x squared. In the middle there, we have 2 times 12x, which is 24x. And then in my last box, I have 2 times 4, which is 8. Then we want to check out, do we have any like terms? Yes, we do. We have 36x squared and 18x squared. We also have 12x and 24x. So when the dust, still in highlighter mode. When the dust settles, we have 27x cubed plus 54x squared plus 36x plus 8. Okay. Very good. So your homework tonight is to do some distributing in Delta Math. Let me know if you need some help. Email me or join me on office hours, whatever you want to do. So I hope you have a fabulous day. Thanks for staying on through all my technology glitches. Always a good time. So have a good weekend if I don't talk to you